Hi guys, welcome back to my mathematics tutorial, and my name is Peter C. Dogba Jr., mathematics instructor at the University of Liberia and your math tutor. In my today's lecture, I want to look at differential equations. And under differential equations, we'll be looking at one of the methods in solving differential equations, especially solving first order and first degree differential equations. So we are still dealing with the variable separable method. So we told you in previous lessons, when you have a differential equation where you can separate the variables, that is putting one variable on one side of the equation and another variable on the other side of the equation, then you can apply variable separable method to find the differential equation solution. So let's look at how we can apply said method on this particular problem. So now we have y dx plus 1 plus x squared tangent inverse of x dy equals to 0. So we can first think of how we can make sure that all of the expressions in y are on one side of the equation, so I would prefer having y on the left hand side. So this term, I maintain this term on this side. Tangent inverse of x dy equals, I send this term on that side of the equation, it becomes negative y dx. So the next thing I need to do is to ensure that where I have the x, all of the expressions attached to the x must be in x. So I can divide this out by y and also divide this out by y. And I can do the same for this, and this is now y. So everything here must be in y. So 1 minus or 1 plus x squared is not in y. Tangent inverse of x is not also in y. So I have to get rid of it. 1 plus x squared, tangent inverse of x. So this entire thing will cancel this one. This y will cancel this y. So now I'm left with dy all over y. And on this side, I'm left with dx all over 1 plus x squared tangent inverse of x. Now the variables have been separated, so I can integrate both sides to find our general solution. Now note that the integral of, or let's say d by dx of tangent inverse of x is equal to 1 over 1 plus x squared. So this is tangent inverse of x, the derivative of tangent inverse of x. So since this is the derivative of tangent inverse of x, and we carefully look at this right hand side expression, now the integral of this one is just ln of y. If we carefully look at this, it can be rewritten in a form wherein we can put this 1 over 1 plus x squared on one side. So we can have it like 1 over tangent inverse of x times 1 over 1 plus x squared dx. So if we allow our u to be tangent inverse, if we differentiate tangent inverse, we're going to get this expression. Therefore, we can say let u equals to tangent inverse of x. So we got du now to be 1 over 1 plus 1 plus x squared times dx. So where we see 1 over x, 1 plus x squared dx, we want to write the du, and this tangent inverse of x is just u. So we have the ln of y equals negative the integral of 1 over u times du. So you have the ln of y negative the ln of u plus some arbitrary constant c. So this is how simple it is. Very, very simple. So now what we can do is to ensure that probably we rewrite this thing. Now you can just bring in the value for u and call this your final answer, or you can further simplify with just ln of y and ln of u. It doesn't matter. But I want to rewrite this c because I know that this c is an arbitrary constant, so it can be represented by whatever constant that I wish to select. So that I can choose ln of c. Now I'm choosing ln of c because I want to simplify ln of u and ln of c. So I have ln of y equals ln of c, right? So I have ln of c. Now this is minus ln of u. I've replaced this now with ln of c. So if I further simplify that, ln of c minus ln of u is equal to ln of c over u. So since I want to solve for y, I can bring in a property that states that e raised to the ln of y is equal to y. So based upon that, I can say let e be raised to the ln of y. I do the same on this side, e raised to the ln of c over u. So e raised to this is just equal to y, and then this is just equals to c over u. So finally, I can have u times, let's say, y equals to c over u. But what is u? U was just tangent inverse of x. So this is the general solution of the differential equation for the problem given. So that is a general solution. So thanks ever so much for watching. See you in our next video. Thank you.